Alright guys, welcome back. We're going to be solving question 81 from the second chapter of Meriam textbook Statics. And we have uneven train conditions that cause the left front wheel of the all-wheel drive vehicle lose its traction. So we're talking about the wheel D in here. And the driver causes the traction forces as shown to be generated by other three wheels. So we have these three forces that are generated in the other wheels. So his two friends exert the indicated forces on the vehicle periphery at point E and F. We need to determine the resultant of the system and the x and y intercepts of the line of action of this force. And we have note in the question that the retroactive vehicle are equivalent, so AD is equal BC, so we have the same distance between A and D and same distance from B to C. The question is telling us to treat this as a two-dimensional problem and realize that G lies on the car center. So basically, if you look at the question, you see that X and Y axis, and the G is the center of gravity for this car. And first of all, we need to find the resultant of all these forces. Actually, we have 5 different forces on 3 wheels. So let's just figure all the forces that we have in here. And obviously, we have forces in X direction. Again, this is our X and this is our Y. So we're going to go based on this direction of positive X. So to the left is positive. So we have the X component of the 160 pounds, and we know this angle is 30 degrees, which means this angle is 30 degrees too. So negative, first of all, 160, and the cosine of 30 would be the X. So I'm just gonna go with the X and I'll do Y after. So we have negative 125, positive. Both of them are positive because the X is to the left. So we have the 40 pounds also positive, and we have the X component of the 60 pounds. We have this angle 20 degrees, so plus 60 cosine of 20 degrees. That's going to be the I component of the R. And now let's move on to the J, or the Y component. 160, as we can see, has downward Y component. Since downwards are positive, so 160 this time will be sine of 30. 85 also has Y component, and at B we don't have any Y component, and we also have one component at F which is upward, so this one's negative 60 sine of 20 degrees. That's going to be our J. All right, so let's see what we get for our resultant. So let's do the X first. 160 cosine of 30 plus 125 plus 40 plus 60 cosine of 20. Yeah, that's going to give us 360i as for the X component. And let's move on to Y. So 160 this time, sine of 20 degrees plus 85 minus 60 sine of 20. The first one was 30. And this is going to give us 144.5 J, and the unit will be in pounds. So that's going to be our resultant force. So if you look at the R, we can see that the R has both X and Y positive. So this will be the direction of R. So this was our Rx, which is what we have in here. This is our Ry, so Ry, and this is going to be our R. And that's going to be the direction of the R. So for finding the intercept with X and Y, first of all, let's just figure out the moment first, because we have to find the moment of all these forces about point G, and from that point we're gonna go find the intercept with X and Y axis. So we are trying to find the moment about point G, counterclockwise, our sign convention positive. So let me just clean up the figure and go from there. All right, so if you're trying to find the moment about G, so let's start with the 85. We can see the moment of 85, first of all, is counterclockwise, so positive 85, and we are interested in vertical distance from G to the line of action. So this distance, which is 14 plus 43. So the force was 85, 14 plus 43 inches, that's going to be the moment of the 85. That's done. We have the moment of 160, so it has two components. We have to find both. And this angle again was 30 degrees. So the x component, we can see it's counterclockwise, so positive. We figured it's 160 cosine of 30 degrees. And the distance that we have in here is the vertical distance to the line of action, or what we have in here, which is basically half of the 61. So 61 divided by 2. We have the moment of the y component of the 160. This one's counterclockwise. So positive again, plus 160 sine of 30 degrees. And the distance here would be the distance from, this is the line of action, so what we have in here, which is 43. So 160 is out. We have the moment of 125. This one's also counterclockwise, so 125. And it's going to have the same distance, 61 divided by 2. So plus 125, 61 divided by 2. This one's out. Let's go with the 40. We can see the moment of 40 about G's clockwise, so negative 40, but same distance, 61 divided by 2. And the last one is the 60 pounds. Again, we have to resolve it in two components. This angle 20 degrees. The moment of the x, we can see that is clockwise, so negative 40 times the distance is going to be the same because it's the same as the 40 pounds. So I don't know why I put the force this, so 60 cosine of 20 degrees, and we have a little bit of different distance because you can see that this point right here is a little bit lower than C, so we have this little distance, which from the question, I'm just gonna clean up, we can see better. So we have this little distance here that is 4 inches, and we figured that this distance is 65 divided by 2. So 65 divided by 2 plus that 4 inches that we have, and that was the moment of the x, and this will be the moment of y. This one's counterclockwise, so positive 60 sine of 20 plus, and the distance that we have is going to be 65 plus 32. And yeah, that's going to be the answer for our moment. Let's see what we get. So 85 times 14 plus 43 plus 160 sine of 30 times 43 plus 125, 61 divided by 2, negative 40, 61 divided by 2, negative 60 cosine of 20 times 4 plus 61 divided by 2 plus 60 sine of 20 times 65 plus. So that's going to be our moment, 15,150 pound inch. And if you want to convert it to pound foot, we know 1 foot is 12 inches, and we're just going to divide this by 12. So the moment about G is going to be 1262 pound foot, and it's going to be counterclockwise. So now that we have the moment, it's pretty easy. We have the moment about G, and we can find the x and y intercept. Let me clean the figure. So we figured that this is the direction of our r. So if you want to find the x-intercept, first of all, the moment of r is counterclockwise. So it has to be in here to line of action cross here. So it's going to be our x, and it has to be in the positive direction. So the moment of this, so if you resolve it in these two, the x component won't make any moment. We have the moment of the y component of r, which is 144.5. So the mg is equal to ry times x. So mgb figured is 1262, ry is 144.5, So the x in here will be, and actually since this is in inches, we're gonna go with our inch unit. So we're gonna keep this one 15,150. So 150 divided by 144.5. Our x is gonna be 104.8 inches. And for finding the y-intercept, we need to keep in mind that the y cannot be in here, because if it's lower, then g is going to make a clockwise moment and our moment is counterclockwise. So the y-intercept is going to also cross it somewhere in here, which is we have a negative y for that. So this time we have the rx times y. So mg would be rx times y. And I'm going to put the absolute value in here, but we know that the y is actually negative. So 15,150 and Rx was 360. So this is going to give us Y. I was going to put the negative sign. So 15,150 divided by 360. And this is going to be 42.1 inches as our X and Y intercepts. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.